remarkably familiar. So, sorry, not that. That's yesterday's lesson. This is today's lesson. We're going to look at some new ratios. The tangent ratio is the opposite over adjacent. Today we're going to look at two new ratios, the sine ratio and the cosine ratio. Now, these are abbreviated SIN and COS, sin and cos, but it's sine and cosine are the actual names, sine and cosine. We just abbreviate them SIN and COS. Simply put, we still have the same parts of the triangle. We still have opposite, adjacent, hypotenuse, but the sine of an angle is the length of the opposite over the length of the hypotenuse. So now we're incorporating the hypotenuse into our arsenal of things that we can use because we only had opposite and adjacent before. Now we have the hypotenuse. Cosine of an angle is the length of the adjacent over the length of the hypotenuse. And as we already learned, tangent of an angle is the length of the opposite over the length of the adjacent. Now, keeping these three ratios straight can be a little tricky, but the phrase we've been using forever and ever in geometry to help keep that straight is the phrase so, ka, toa. Stands for sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So, ka, toa. Say it out loud. Memorize it. So, ka, toa is your friend. Everybody who's been through geometry and trigonometry has learned so, ka, toa. And please don't say it wrong. It's so, o, long o, ka, like ah, toa, oa. The o-ah, very specific order, so use your phonics there. Very important. Sine, cosine, tangent. So if I have a triangle here, I have triangle RST. It wants each solution for sine S, sine R, cos S, and cos R as a fraction, as a decimal to 4 places. So let's start with sine of R. So I'm going to put this R, sine R, cos R, and let's do sine S over here and cos S over here. So sine of R. Well, R is my perspective. When R is my perspective, the 16 is the opposite side. The 65 is the hypotenuse, and 63 is the adjacent. So just like before, the first thing you want to do is establish perspective and name the sides according to your perspective. The sine of R is the ratio of the opposite over the hypotenuse. The opposite is 16. Hypotenuse is 65. And when I put that into my calculator, 16 divided by 65, that's about 0.2462. The cosine of R is the adjacent over the hypotenuse. The adjacent is 63. The hypotenuse is 65. And when I take 63 divided by 65, I get 0.9692. So I'm able to find both those values. Now, not hard to do. I had to remember which side goes with which. We set up the ratio. We find the decimal. We're great. What happens when I switch my perspective to angle F? Well, my perspective comes over here. 65 is still the hypotenuse, but now 63 is the opposite and 16 is the adjacent. The sine of S is still the opposite of the hypotenuse, which is 63 over 65. Oh, that was the same as the cosine of R. So I know that's about 0.9692. The cosine of S is the adjacent of hypotenuse, which would be 16 over 65. oh, that was the same as the sine of r. 0.2462, approximately. So a couple things I noticed pretty quickly. R and S are complementary angles. They add up to 90. They have to, because that's how many degrees are left in the triangle after we take away the right angle. And I notice that the sine of R is the same as the cosine of S. The sine of R is the same as the cosine of its complement. And the sine of S is the same as the cosine of its complement. So we have a relationship between sines and cosines within a triangle. I noticed something else. In both sine and cosine, the denominator is always the hypotenuse. Okay? Hypotenuse is always the denominator in the sine and cosine. And the hypotenuse has to be the longest side of the triangle. So if this is always the longest side down here, and this is always shorter on top, not always a whole lot shorter, but always shorter, that means this ratio can never have a value greater than 1, can it? Tangent can be any value you want, but sine and cosine cannot have value greater than 1 because the hypotenuse is the denominator. So little things we figure out very quickly about these ratios. Now we do have a relationship here that we were just talking about, that the sine of an angle is cosine of the complement of the angle in a right triangle. And the cosine of the angle is the sine of its complement. This is going to show up a little bit in your homework. It's not a very difficult concept. It says write sine 56 in terms of cosine. It's really a very simple process. If it's sine of 56, that's cosine of 90 minus 56. And 90 minus 56 is 34. So sine of 56 is a cosine of 34. Not sure? Try it in your calculator. Find sine of 56 and the cosine of 34. They're going to give you exactly the same decimal value. If I said find cosine of 81 degrees in terms of sine, well, cosine of 81 has to be the same as the sine of 90 minus 81, which means the sine of 9 degrees. So these two have exactly the same value. Not sure about that? Well, think about it for a second. Let's say I've got a triangle here. I've got an 81 degree angle, a right angle. This angle has to be 9 degrees. And if I find the sine, if I call this angle A over here, the sine of angle A is, I'll call these X, Y, and R for now. Okay? The sine of angle A, actually I'm going to switch the X and Y. Well, okay. The sine of angle A is X over R, opposite over hypotenuse. And the cosine of this angle B down here is the adjacent over hypotenuse, which is the same thing, X over R. So it works every time. Now you can be asked to do something like this in the bottom. You're just going to be asked to do the cofunction. All right, now it says find sine D, sine F, cos D, and cos F. Write each answer as a fraction, as a decimal, around to 4 places. I'm just going to ask you to do one thing here, one thing for the quiz, and that's find the sine of F as a ratio. So sine of F as a ratio. That's your first question for today. Now it says find the sine and cosine for a 45-degree angle. Well, for a 45-degree angle, well, how do I know anything? I don't know the sides of my triangle. How can I find the sine and, oh, 45-degree angle. A 45-degree angle is one of my special triangles. X, X, X root 2. Remember, we said we had to memorize that very carefully. It's back. Find the sine of a 45-degree angle. Which 45? It doesn't matter. Pick one. which means this side is the opposite, this side is the adjacent, and this side is the hypotenuse. So sine of 45 is the opposite over the hypotenuse. The x's cancel. That gives me 1 over the square root of 2. Now, little square root review. We aren't leaving square roots in the denominator, so I have to rationalize. I rationalize by multiplying by 1 in the form of whatever the square root is over itself. Because root 2 over root 2 equals 1. 1 times root 2 is root 2. Root 2 times root 2 is 2. My exact value is the square root of 2 over 2. That's the sine of 45. If you don't remember this triangle, this special triangle, put it in your notes, make a flashcard of it, memorize it. You need to know it. It keeps coming up. Our other triangle is a 30, 60, 90 triangle. And this is one that keeps coming up as well. It says find the cosine of a 30-degree angle. Well, first we're going to have to start with my 30, 60, 90 triangle. And remember that my sides in the 30, 60, 90, the shortest side is my base side, n. My hypotenuse is twice as long, and my adjacent side, or my middle side, is n times the square root of 3. So if you don't have that triangle memorized, make sure you pause the video, jot it down in your notes, get it memorized. Now, if that's my triangle, I want the cosine of 30, that means I'm down here. So this is the opposite. Obviously the hypotenuse. This is the adjacent. The cosine of 30 is the adjacent over the hypotenuse, ka. So ka toa, cosine adjacent hypotenuse. The adjacent is n root 3. Hypotenuse is 2n. Guess what? The n's cancel, and I get the square root of 3 over 2 is the exact value of the cosine. Don't need to simplify that one because the square root's on the denominator. You're in the numerator. It's not a problem. These are the types of problems we're going to deal with. And again, find the sines and cosines exact values of some of these identity triangle angles. Again, absolutely going to be huge. If you take pre-calculus, this is a major, major, major concept in pre-calculus that we're looking at and just kind of touching on here in geometry. That said, let's find the sine and cosine of a 60-degree angle. Now, I'm going to give you a little bit of a hint. We're going to go ahead and draw my triangle. Okay. This side's n, this side's 2n, this side's n root 3. Here's my 60 degrees, here's my 30 degrees. So we want the 60-degree angle. You find sine and cosine. And that pretty much does us for today. Have a great rest of your day, and I'll see you in class.